So I thought it would be helpful for me to go through these. So this is section 5. Whoops. Section 5, the end problems. Most of them you did in Zoom yesterday, and I'll just let you know that I changed some of them. So this is different than what your handout has, right? Okay, so just letting you know. So let me walk through. So if you have an if, then, and it has a subset, and I'm trying to prove it's true, or found the counterexample that it's false. So I start to just think about it. Okay, so if A is a subset of C and B is a subset of C, then A or B is going to be a subset of C. So that makes me think it's going to be true because A and B are contained in C. So the union will be contained in C. Okay, so you always want to start here. So you want to pick an element in A or B. So that means X is an element of A or X is an element of B. Okay, so now this is where you pull the if in. So then I would just make sure you're having a conversation with your reader. Since A is a subset of C, this means X is an element of C. And then here I can say since B is a subset of C, this means X is an element of C. So look at that. I get X is an element of C. I got there. All right. So again, we have an if, then. So you want to pull in this after you start here, right? You always want to start here. All right, so I'm going to say a big X because I want to say it's a set, right? So if X is an element of the power set of A, then what that means is that X is a subset of A. That's a big deal, right? So maybe my element sign should be a little bit better. So this is an element of, right? This is a subset. And so now I say, oh, wait. Since A is a subset of B, and I have this and this means that X must be a subset of B. Oh, and what does that mean? That X will be an element of the power set of B. A subset will be in the power set of B. Okay, when I typed these up last time, I had the word if on these guys, and they shouldn't have been. So that was kind of confusing. Another reason for me to redo these. All right, so let's think about this. So if I have an A union B, a set A and B, and I join them together and I find all of the sets of subsets, is that going to be contained in the power set of A joined together with the power set of B? Wait a minute. If I just think of like an A being just 1, 2, and a B just being the set 3, don't I know that inside of here I would have the set 1, 2, 3, right? That would be an element of the power set of A and B together. So power set of A and power set of B, they're just going to have them separately. This is not going to be in there, is it? Okay, so like we can even just write them out. So the power set of A with my example would have null set, would have the set 1, would have the set 2, would have the set 1, 2. Okay, power set of B would have the null set, and then the set with just 3 in it, right? So, and if I wrote out what the power set of A or B is, right? So that's conjoining all of the set together. I would have, and I'm just going to put ... I would have this set in here, but it's not in here. So I would say the set 1, 2, 3 would be an element of the power set of A or B, but not in the power set of A, union the power set of B. Okay, so what if, and this is new, this was not on your paper before, is it true the other way? Is it true that if I take the power set of A and join it together with the power set of B, that it will be contained in here? Just even thinking about this example, I do see that's going to be true. So first I have to say, okay, let's take a set and make it an element of the power set of A or the power set of B. So that means that X is an element of the power set of A, or X is an element of the power set of B. So that means X is a subset of A, right? Because if it's an element of the power set, it's a set that's in A, or X is a subset of B. So that means X is a subset of A or B. And what does that mean? If it's a subset of A or B, that means that X will be an element of the power set of A or B. It's going to be one of the subsets of. All right, so let's look at this one. So this is saying if I have the power set of these Cartesian coordinates, so an A cross B element is going to be an XY point, correct? So let's just even keep it real simple. So let's make A equal to 1 and B equal to 2. So the A cross B elements, right, would be 1, 2, right? That would be the A cross B elements. Okay, so the maybe let's make that let's just do a little bit more. So let me make this 2, 3. So then it would be 1, 3. So at least I have 2 elements, right? So these are the A cross B elements. So what are the power set of A cross B going to be? Okay, so we always have the null set. I'm going to have the set that has this ordered pair. I'm going to have the set that has this ordered pair, and I'm going to have the set that has both of the ordered pairs in there, right? Because the power set is going to have the number of elements will be 2 to the 2 power, right? So there's 2 elements to that square, the 2 power. Okay, so that's what this side is looking like. So now let me just change colors. What are things on this side going to be? All right, so this says the power set of A cross the power set of B. So the power set of A, whoops, I meant to do black. Okay, black. No, it's not changing for me. There it is, black. Okay, so power set of A. Power set of A will be, whoops, the null set and then the set 1. The power set of B will be the null set, the set 2, and the set 3. Whoops, and the set that contains 2, 3, right? Okay, so that's the power set of A, there's the power set of B. So what does an element on the right-hand side look like? So the power set of A cross the power set of B is going to be an ordered pair. So what do these elements look like? The elements would look like an ordered pair. So the X will come from here, right? So I'm just going to pick this. So it's got the set 1 as the X. And I've got to pick something from the power set of B for the Y. So I'm going to pick this. Oh my goodness, right? So that's a parenthesis, right? So that's my ordered pair that has sets in it, whereas this has ordered pairs within the sets. So different elements. Remember we used the word different animals in linear algebra. So they're totally different elements. So as soon as you write one element out and one of these elements out, you can say they are not the same. So this one here is going to be the same, right? So you could just make an example. So they're different elements. Oh, and look at that. I put the same thing. This is E again, so you can just cross that right off. Okay, so you could have this one or this one. At most, you will have, one of these on the test, right? Where you have to prove true or show with a counterexample.